Yep.
Thank you very much for this invitation. And my name is Todor Ganchev. I'm from the Technical University of Varna, and I will give you a brief introduction to foundations of artificial intelligence. So today our objective is to get a feeling about artificial intelligence and to get inspired to continue thinking, learning, and creating the future of artificial intelligence. This is a lifelong challenge. AI is much more than some new technology. We'll discuss about that. I would like to start with a nice sentence from Mr. Buchanan, who wrote a very brief history of artificial intelligence. I recommend for you to read it. But he says that the history of artificial intelligence is a history of fantasies, possibilities, demonstrations, and a promise. And it started long ago in the writings of Homer, 750 years before Christ. He speaks about automatic tripods of the gods. These tripods serve the gods' specific needs. So these are automated creatures that were invented very, very long time ago, at least in the writings of Homer. And then comes the mechanical man named Tick-Tock. This is from the books of Lehman Baum, the wonderful Wizard of Oz. Actually, it is a book series that includes 14 books. Probably all of us know about the Wizard of Oz and the Tick-Tock and the nice adventures they had. And as the author put it, Tick-Tock is extra responsive, thinking, perfect talking, mechanical man. He thinks, speaks, acts, does everything, but live. To live. What does it actually mean to live? This is not a simple question, actually. One thing is to be alive, different thing is to live, although in the dictionary they are very similar. So let us think about AI. Of course, we won't be the first. Before us, in the 20th century, Isaac Asimov have taught a lot about artificial intelligence. And he's a scientist, biochemist, but not only from the scientific perspective. He has a very nice perspective from the human point of view. And in his book, I, Robot, published in 1950, Asimov speaks about robots, humanoid robots that serve humanity. And then in this book, he invented the 3 laws of robotics. This generalized that a robot may not injure a human being, or through some action or inaction will not allow human being to be harmed. And the second law is connected to the fact that robots should obey orders given by humans, except if such orders would conflict with the first law. And then a robot, as a conscious being, should be able to protect itself, unless this is in conflict with the first and the second law. This is really very nice because years before artificial intelligence was created, there were people thinking about the implications of this. And there are other books of Isaac Asimov. I recommend really everybody to read Foundation and Empire, and the Second Foundation, where the author really thinks what is going on to happen. He writes about the galactic empire, the foundations of civilization, and he invents the psychohistory, which is very, very interesting perspective to what we are doing today and how we are doing this. I really recommend this book. And of course, the best are Bicentennial Man and the Positronic Man. They are describing a robot who dreams to become a man. He wants to be a human. That's an amazing story. I really recommend this in order to understand the deep meaning of artificial intelligence. What does it mean to be intelligent? Really, very, very nice story. And why we are talking about that? Well, for good or for bad, we haven't reached the singularity point yet. According to Professor Ray Kurzweil, singularity will occur around year 2045. That will be the moment when artificial intelligence is more intelligent than humans. Nowadays, there are various unsolved problems of artificial intelligence. And unfortunately, most of those are linked to the complex nature of ethics, moral, social stereotypes, acceptability of technology, and many other problems that are problems of humans, not of the robots and artificial intelligence. And of course, there are other complications that hinder the acceptability of artificial intelligence. And these are again connected to humans. Humans simply cannot imagine the moral, social, and legal consequences following the emergence of artificial intelligence. And what follows after the singularity point is reached? What follows when artificial intelligence becomes smarter than humans? I like the way Elon Musk puts all this. In one of his interviews, he said, the biggest mistake that I see is that artificial intelligence researchers are assuming they are intelligent. They are not compared to AI. And so a lot of them cannot imagine something smarter than themselves. But artificial intelligence will be vastly smarter, vastly. So what do you do in a situation like that? Let's think. What do you do? Let's hope artificial intelligence will be nice with us, with humans. At this time, we just have this answer. We have no other answers. What we do? Maybe this is important to know. And maybe this is why young people should care about the artificial intelligence. And then comes the motivation why young people should go in this direction. It could be quite simple, really. Just you can follow the old saying, the old wisdom, saying that if you cannot beat artificial intelligence, simply join artificial intelligence. If you read history of war, that's maybe the best approach. This wisdom is quite old and valid. So in this context, we as humans shall mostly care about creating humanistic AI. Under this name, please consider technology that will help and support humans in order to enhance our cognitive capacity, to strengthen our bodies and mind, to help us solve problems we are not able to solve on ourselves at this time. There are other kinds of future which is also possible, and consider one of those when artificial intelligence is used mostly for war. Currently, we are witnesses of drones that attack the bad guys with weapons. This is one opportunity, one possibility. Artificial intelligence could be an instrument for control and power enforcement. Of course, artificial intelligence could be aligned with the human values, ethics, and so on. These are the choices that we make today. Fortunately, in Europe, we have legislation. We already create this legislation, and many countries accepted it. But for now, the United States, China, Russia, all the other big players in the AI community still hesitate. They are thinking about that. So today, my speech will be about the 4 perspectives towards artificial intelligence. I will speak about basic concepts and will briefly introduce my course on fundamentals of AI. This course will be available through the Cloud Earth Hub that is currently created. And I will talk about agents, decision-making, classification tasks, classification approaches, and will give you one example of application that is somehow related to artificial intelligence. Don't expect talking robots, please, not this. As I said, it is a lifelong challenge to learn about artificial intelligence. Please consider some important books. I recommend highly the book of Russell and Norwick, Artificial Intelligence, A Modern Approach. This year we have the 4th edition, and this book is used in the artificial intelligence course of 1,500 universities around the world. It is the Bible of artificial intelligence. And I really recommend it to you because it is written for the general public. It is not only for engineers. You will not find too many equations there. It is just the book for everyone to start with. Another book, Paul and Mackworth, Artificial Intelligence, Foundations of Computational Agents, is a very gentle introduction also to agents, to artificial intelligence problems and ways to solve them. And for those who really want to understand the philosophy of artificial intelligence, should read the great book of Marvin Minsky, The Emotion Machine. There, Marvin describes what is intelligence. We all know what is artificial, right? This is something created by human, okay? Artifact. But what means intelligence and how to become intelligent? Marvin Minsky puts in very, very nice way that to be intelligent means also to see the same situation from different perspectives. And how we do this? The humans, I mean. Okay, we can have one of these mechanisms through emotions. Emotions influence our perceptions. The same fact could have different interpretation based on our emotions. So the same observation could lead to different decisions based on our emotions and the context. Please consider this book seriously if you want to advance in artificial intelligence. Marvin Minsky is one of the pioneers of artificial intelligence, and this book has 60 years of experience and wisdom, concentrated in 120 pages. So, what does artificial intelligence actually means? You will read in some books that Artificial intelligence studies the synthesis and analysis of computational agents that act intelligently. What does it mean to act intelligently? The scientific goal of artificial intelligence is to understand the principles that make intelligent behavior possible in natural and artificial systems. And this is done by analysis of natural and artificial agents, humans and animals, and many other creatures are also agents. I would give another more strict explanation what an agent is a little bit later there. But then the second point is by formulating and testing hypotheses about what it takes to construct intelligent agents. This is the second scientific goal. And then there is a third one, designing, building, and experimenting with computational systems that perform tasks commonly viewed as requiring intelligence. So these are mostly tasks that we humans do, and we believe this is intelligent. And from the engineering point of view, artificial intelligence is to design and synthesize useful, intelligent artifacts. That means to build agents that act intelligently. And of course, they are useful. They have specific use and purpose. So, what does it mean to act intelligently? Not an easy question, actually. And in theory, in the artificial intelligence theory, there are four perspectives, four different points of view. And one comes from the ancient times and goes into direction of thinking humanly. They analyze the logic and they analyze the way human brain works and try to recreate this in artificial way. Thinking rationally comes from ancient Greek philosophers who invented logic and way to manipulate items and from one item to go to another and to follow some path that is logical. That means it's reasonable and can lead to result that is useful. But that's all about thinking. What about acting? One of the directions is to create artificial intelligence that acts like a human. Oh, do we really want this? Human beings are quite messy. Do we want to mess up also with robots that are not reliable, not predictable, that violate rules? I'm not sure at this time. So the current perspective to artificial intelligence is to create machines that are acting rationally. They are predictable. They do the best thing according to specific criteria, and they are useful. So, speaking about artificial intelligence, we advocate the perspective that what we need currently is not general artificial intelligence that is equal or matching the functionality human can deliver. We have specific purpose to create intelligence that helps us in everyday life. When I say we, I'm engineer. That means the engineers and scientists who work on artificial intelligence today. So, a system is considered rational if it makes the best decision and takes the appropriate actions with the information available at the specific moment. In the book of Russell in Norwich, this point of view is advocated, and you can read a lot about the different perspectives and the different schools of artificial intelligence. And I really recommend that you get familiar with these 4 different perspectives, because it is quite important to make the difference and to realize why I'm saying all this. What we are going to talk about today is mostly about computational intelligence, AI that is oriented toward creation of rational agents and rational systems that are useful. Let me just briefly mention the other perspective from let's say good feelings to the past. Remember that year 1950? It is the year when the iRobot book was written. It is the same year when the first article on artificial intelligence was published. Alan Turing published in 1950 an article called Computing Machinery and Intelligence. And this was the first article that discusses the question, can machines think? Can machines behave intelligently? And in that article, Alan Turing also defined the imitation game. It is the Turing test. It is about a way to realize if a machine is intelligent or not. So basically, we have the following concept: 2 different rooms. Oh, where is my mouse? Can you see my mouse now?
Yes,
we have 2 different rooms, and in the one room is a human judge, somebody who sits behind a computer and types on the keyboard. And then in another place, remotely, there is either a human or a computer system, and the judge doesn't have information who is on the other side. And then Alan Turing says, if a computer can deceive a man for about 5 minutes, that he communicates with a real man, that means artificial intelligence is achieved. Of course, there is some soft, let's say, some softening of this. In fact, Alan Turing says, if manages in 30% of the cases to deceive the human, that means that artificial intelligence is achieved. Not in 100%, in 30%. And Alan Turing suggested that by year 2000, machines will be able to deceive humans, that they speak to another human. Ray Kurzweil pointed us 2029. Chatbots will be so efficient and so advanced that humans will not have clear idea if they are talking to another human or to a chatbot. And then in 2045, the singularity point will come when artificial intelligence can do everything humans do and will be even smarter than we are. So the Turing test was created as an instrument to measure how smart is a machine and if artificial intelligence was reached. But this is somehow in the territory of acting humanly. This direction was followed for almost 50 years, and researchers were trying to understand how human brain behaves and works, and trying to replicate those behaviors. So we create machines that are acting like humans. Nowadays, this is obsolete for now, I hope. So basically, in order to summarize, Alan Turing suggested that by year 2000, artificial intelligence might have 30% chance of deceiving untrained human for about 5 minutes. Of course, he was wrong, but not so wrong. What is nice that Turing defined the building blocks of an artificial intelligence system, and he clearly made it clear that such a system should have knowledge representation and storage module, and then autonomous thinking and reasoning module, and then natural language understanding module, and then some sort of machine learning components that are able to learn from the experiences. And what I want to really emphasize here is that artificial intelligence builds on the convergence of knowledge from various fields of science, starting from philosophy, mathematics, economy, neurobiology, physiology, computer engineering, engineering in general, control theory, linguistics, law, ethics, and many other sciences. Here, I could boldly share my personal opinion that and belief that humans artificially divided science to many subjects. This was done intentionally because of convenience. Of course, it would be nice to say that I'm expert on philosophy or I'm professor of mathematics. This is very convenient. You define your area. But I would expect, or oh, sorry, I touched something. What to expect? I would expect that before the singularity point is reached, humanity will witness a convergence of all knowledge and will discover the unified science, the theory of everything, the theory of cosmos and consciousness itself, the theory of spirit and matter, stars, planets, flora, fauna, everything in one theory. And believe it or not, this unification will be made by the artificial intelligence. Different fields of science will merge, they will be harmonized. And then a very deep understanding of the processes in the universe will be reached. Of course, this is opinion that I advocate, but let's see if this will happen or not. So, some history when it started. It started long ago with some, let's say, designs. It is electric circuit design that makes automation, that makes automated decisions. McCulloch and Pitts built a Boolean circuit model, electric circuit that models decision making. It is automation, some sort of automation. Then in 1950, Alan Turing published his article on computing machinery and intelligence, and that was the start of AI. And then in the 50s, 60s, and 70s, there was much of excitement, and people started to develop automation. At that time, because of the military industry, because of the space industry, automation was kind of important. And many people started to get involved in military projects like the space programs and rocket programs of Soviet Union and USA, UK, and other countries. And scientists started to think more general. What is to create autonomous algorithms? What is to create systems that make decisions on their own? And at one conference in 1956, the term artificial intelligence emerged. Artificial means created by man. Intelligence means that is able to learn, is able to think, and is able to create new knowledge or make something that has not been created so far. So intelligence here is in the wide sense of thinking, making decisions, learning, and creating. And later on in the 70s and 80s, experts worked on knowledge-based approaches. These are the expert systems that we know. If you ask somebody my age, what is artificial intelligence? And then he will immediately say, oh, that's an expert system, because these were the applications of 80s and 90s, and we have many of them. And from the 90s, artificial intelligence became science in the meaning that researchers started to accept the probabilistic approach. And most of the artificial intelligence systems nowadays are dealing with probabilities. They are capable to deal with uncertainty and with the lack of information. So in the 90s, the intelligent agents emerged as a concept. What about the 20th century? Okay, that 21st century brought us artificial intelligence technology in everyday life. Probably many of you have seen or own the automated vacuum cleaner, iRobot, or some others. In 2011, the assistants Watson and Siri were created, and even later on, many other operating systems and companies created their intelligent assistants. And then in year 2014, some software passed the Turing test because 1/3 of the judges got convinced that they are speaking to 13 years old boy called Eugene Gustman. The same year, Alexa assistant emerged. Probably these are things you already know. What comes next? What do you think? What is the next everyday technology that we will start using? It's not easy, but I would guess these are driverless cars. These are the cars of the future. Let me mention a few achievements of artificial intelligence, and then I will go on with the interesting part of my lecture, which is about the details. The first great achievement of artificial intelligence is 1997. A computer built by IBM, Deep Blue, defeated the world champion of chess, Garry Kasparov. Later on, it was demonstrated that computer algorithms can solve crosswords better than humans. In 2011, IBM Watson wins against the champions Brad Rutter and Jennings, a game called Jeopardy. In 2015, DeepMind's AlphaGo defeated the European champion of the Chinese game Go, which is much more complex than chess because of the many more millions of variations you may face during the game. And then some years now, starting from 2008, I believe, Google and some other companies are working on driverless cars. Toyota, Honda, Chrysler, and Apple also, they have their own projects working on driverless car. Here I want to mention that there is an international society that defines the level of automation. So level 0 is the car I'm driving, no automation. And then level 1 are the cars that have shared control. You still hold the steer, but the steering wheel, but some options, some functions are automated. And then level 2 is when you don't need to hold the steering wheel. You switch on the autopilot, and then you're no longer a driver, you're a passenger. And then at level 3, you don't need even to follow the road. This is the situation where most of the car producers are now. You have a safe trip. You don't need to watch the road all the time and grab the steering wheel if something goes wrong. And you still, let's say, are conscious that something may go wrong. You know, this year there were several accidents with driverless cars and with some people killed and some injuries. But this is the technology today. What follows tomorrow is then when you enter the car, you don't care about how the car is going and what is the road and what is the traffic and what are the conditions. You just want to go somewhere and order the car to drive you there. And the next level 5 is when cars do not have steering wheels. You can enter a fully autonomous taxi or another vehicle that just drives you wherever you want. No limitations. Why I'm saying this? Because this is coming. This is coming very soon. Most projects will be finished or will reach commercial maturity within 2-3 years. At least these are the current plans. Of course, we also enjoy real-time voice translation. Skype has such technology, and other companies are working on that. I speak in Bulgarian and you hear in English, probably. And what is interesting that Elon Musk also starts to invest in artificial intelligence. And this year he announced his plans for AI implemented into the financial markets. And then he announced another initiative related to brain-computer interfaces. He will create neurochips that widen the channel between human and computer. Now the channel is not very wide because we either speak to a computer or type, or the computer is monitoring through cameras and some other sensors. This is the weak side of communication, no direct link between the human brain and the computer brain. So Elon Musk decided to work on that. And then there are many other appliances for human-machine interaction, for object control, for people with disabilities and missing limbs. You will see many things on internet. People are working hard. But in order to conclude with this introductory part, I would like to show you an image I borrowed from internet. And this image is very nice because it shows what is going today. There are some fields some tasks that nowadays are better done by computers than with brains. And these are all tasks related to information processing, input and output of information, all tasks related with memory. We as a humans, for good or for bad, we forget. Computers don't. There are many, many other tasks where computers and humans behave almost the same. And this is in vision tasks, recognition of objects, language, and some decisions related to very well structured problems and complex movements and precise mechanical tasks. Humans and machines are equal nowadays. And then there are still some tasks related to creativity, emotions, empathy, planning, consciousness that we humans perform better. This won't last long. Nowadays, computers and artificial intelligence in general can do 75% of what human nervous system can do. That means computers advance very fast. 75% of what we can do can be done by computers with the same or better accuracy and more reliable, in a more reliable way. Are there any questions to what I said already, or we move forward?
Actually, there is yeah, there is one question here. Yes.
Yes, please.